Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. I'm Agus Triono. My college is Agus Triono and Sion Harki. We are from University of Jember, and this time we want to present our research. The title is PLC-based cooking oil filling machine automation to increase production efficiency. This is the background for our research. This is a sample of oil cooking package in home industry. How to make it accurate of the volume oil cooking machine is the challenge, because sometimes the volume is not accurate. So if it's not accurate, it make losses for to the home industry or the consumer. So in the study, we want to make a tool machine tool to to make it more accurate than the manual packaging. This is methodology of our research. We have to prepare the hardware and software, then assembly the hardware and try to assembly that machine. If it's feasible, we can test the performance and analyze the performance and the result of the oil cooking packaging. This is the filling machine diagram. So in this filling machine, there are two electrical pump. The first electric pump is to fulfill the oil cooking to the tank. The second electric motor is to fill the cooking oil to the package. And this, you can see that this is the limit switch. But if we only use the limit switch to measure the volume of cooking oil, this cooking oil is not too accurate. So we have to use the encoder to count the volume of cooking oil. This is a rotary encoder, limit switch, the buffer tank, the solenoid valve, and electrical pump. To make it sure that the volume of the oil cooking is suitable and accurate to the package that we want. This is the control box module and PLC programming. This is encoder. This is proximity 1, proximity 2. And the first step of this program is ensure that proximity 2 is on. If proximity 2 is off, so we make it on first, then check the motor on pump 1 on or off, solenoid valve 2 is on or off, and then check limit switch. Limit switch is on or off. If limit switch off, we can back to this step. If limit switch is on, we're next to the next step to count the counter until the sum of counter is achieved. After that, we check the motor and pump 1, solenoid valve, pump 2, and solenoid valve. And then check the proximity 1, on or off. If proximity 1 off, we back to the step. And if proximity 1 on, we go to the next steps. Then check the motor and check the limit switch. If limit switch is off, we back to the step. And if limit switch is on, the computer reset the pump 2, then the packaging is finished. This is a calibration of rotary sensor and counter, because if we use only the proximity, so the measurement of volume of oil cooking is not too accurate. So we use the encoder to count the volume of oil. This calibration is carried out to determine the setting value on the counter. Calibration is performed by trial and error, namely by conducting filling experiment into the bottle with a counter value of 500 points to 130,000 points until obtaining a weight of 690 grams of cooking oil. This is the result of this machine. This is the performance measurement. We can see the difference of manual method and measurement methods. The blue dot and the blue line, this is, you can see that the error is more high than the measurement method. You can see that the measurement method, the red line and the red dot is more stable than the manual method. And this is the graph of filling speed measurement. So we can see that manual method is more error, is not stable, but the measurement method, we can see that it's more stable than the manual method. We try it to the 25 sample to ensure that the measurement method is more stable than the manual method. So the conclusion of this research is, in the cooking oil filling process, the measuring method with the machine affect the production result. This is proven by the experimental data that have been carried out on each method. The manual method has an average filling speed of 545.98 liters per hour, and the experience 0.65% error. This is due to the volume measurement poured into the bottle using the operator's estimation. Additionally, the manual method doesn't use a pump at all and only relies on pressure from the cooking oil storage tank. Second conclusion, the measuring method has an average filling speed of 579.13 liters per hour and experiences 0.19% error. This is because the manual method uses an electrical pump with a flow rate of 60 liters per hour and a rotary encoder as the main sensors in the buffer tank for reading the volume to be poured into the bottle, resulting in accurate and precise result. And the third conclusion is the measuring method has a better production capacity than the manual method, which is 4,633.04 liters a day in this method, and 4,367 liters a day in the manual method, with a difference of 2 to 6 liters a day. Yeah, this is our presentation. Thank you for the attendance.